Hello everyone. Today we are going to look into relations, functions, a vertical line test, function notation, domain and range. A relation is a set of ordered pairs where x represents your inputs and y represents your outputs. These are written in set notation. This example here is set notation. Set notation start with squiggly brackets, and we will have parentheses around each set of ordered pairs, and then we will close the squiggly brackets. A function is a set of ordered pairs or equation whose x values input are matched with only one y value. Every relation has a chance to be a function, but in order for a relation to be a function, we must have x values to be matched with only one y value, only one output. When I look in here, x value, x value, x value, each of the x value, each of the different x value is paired up with one y value, so this relation is also a function. Functions are special type of relations. A vertical line test is a method of determining whether a relation or equation is a function from a given graph. We will use this test whenever we were given a graph. Function notation is a way to name a function using the symbol f of x instead of y. It reads as the value of f at x, or f of x. Domain is a set of x values, inputs. Range is the set of y values, outputs. Go ahead and pause your video in here, and we are going to continue with the next phase. Let's look at these examples. Whenever our values are given in a Venn diagram, we have three values in the domain set. Domain is on the left and range is on the right. Domain is on the left, range is on the right. From domain to range, we have 0, 5, 10 paired up with 1, 4, 6, and 8. Our 0 value is being paired up with 4, and at the same time it's being paired up with 8. 5 is matching to 6, and 10 is going to 1. In order to determine whether a relation is a function or not, we need to check to see if every x value, if every domain value is having only one y value. In our example here, 0 happens to be paired up with both 8 and 4, which will not make a function. In order for this to be a function, you should have every x value paired with only one y value. Even though it's a relation, we can still make a list of elements, items in domain. We will use the squiggly brackets, and we will list everything on domain 0, 5, and 10. Close brackets. Likewise, I can create my range set. This is range set opened, 1, 4, 6, and 8. These are different types of set notations. This is a Venn diagram. This is how we would use or show items in a Venn diagram. And these are list methods. We are going to show the sets in lists this way. As far as answer, our first example is not a function, but it is a relation. Every relation has x values and y values, but when it has every x value paired up with one and only one y value, then it becomes a function. So some relations are functions, but every function is automatically a relation, since functions are special type of relations. Let's look at our next example right here. This is another way of showing a set. We have a table here. I have x value domain, y value range. Domain range. When I look at the domain values, 3 is paired up with 1, 6 is paired up with 2, 9 is paired up with 2, 12 is paired up with 1. Every item in domain is being paired up with one and only one y value. In this case, we have a function. If I were to make a list of domain, I will do 3, 6, 9, and 12. If I were to make a list of range, I will write 1, 2. Because 2 is repeating, you don't have to write it twice. 1 is also repeating, you don't have to write that twice either. And I close my brackets. It looks like our x values are paired up with y values, but none of the x values are trying to be paired with two different y values. So this is a function. Yes, it is a function. Is the relation? Yes, also relation. Here is your U-tries. Check to see if any of the domain values, domain x are same thing, domain values, if any of the domain values are going to two different y values, two different range values, then it's not a function. As long as every item, every domain value is paired up with only one y value, then it's a function. If you were to given a graph, from that graph we have x values and y values on every graph, and each of the points on a given graph are ordered pairs. And whenever we are given a line, this line has ordered pairs throughout. We can determine whether these ordered pairs create a function or they are just a relation. I fill in between the points too, because although I pick nice points, in between the points are still ordered pairs where we have decimal values. Vertical line test will require you to pick your pencil, make a vertical line with your pencil, and then carry your pencil around from left to right or right to left, and your pencil should be touching to the graph only one point at a time throughout the graph. So at this point my pencil is touching only in one point. If I move it here, pencil is touching only one point. If I move it here, only one point. Throughout this graph, my pencil is touching only one point at a time. Therefore, first graph is yes, it's a function. When I continue dragging my vertical line, I see that right here is touching one point. That's good. Continue straight, 1 point, 1 point, 1 point, but at this level right here I have more than 1 point touching right here and right here and right here. As long as it's more than one, it's not a function. It doesn't matter whether the rest of the function was, the rest of the graph was nice and 1 point, as long as we see at least one area where we have more than one points touching to the vertical line, then it's not a function. You can already guess the next one is touching 2 points at every place except the corners here. It's still not a function. Our last one, 1 point, 1 point, 1 point, 1 point throughout. So yes, this is a function. Here is your U try.